Welcome to Bonhill Geography. This video investigates the features of lower course river landscapes, including levees, floodplains, and estuaries. Levees are natural embankments that form along the edges of a river channel. They're created during periods of flooding, when the river overflows its banks. Now, as the river floods, it loses energy and the friction between the water and the land increases as the water has to travel further. Now, this causes the river to deposit its load, with the heaviest materials like these rocks being carried by the river being dropped first. These are closest to the river channel. Over time, deposits like this will build up to form levees either side of the river. These are like natural embankments. Levees act as a natural flood defence, helping to contain the river within its channel and reducing the risk of flooding. However, the river channel's depth can decrease due to deposition over time. This can lead to the water sitting higher than the surrounding floodplain. Unless rivers are dredged to increase the depth, like we see an example of in the background here, this can significantly increase flood risk, where the floodwater can easily spill over the levees and onto the floodplain. Behind the levees, we find floodplains. These are flat areas of land which are periodically flooded by the river. The deposition of fine silt and clay during floods make floodplains very fertile, which is ideal for agriculture. Here's another little video to really emphasise this point. As the river overflows onto the floodplain, that water's spreading out and it's really slowing down due to that friction with the grass. As a result, we can see lots of deposition happening, particularly with that fine silt and clay. Okay, now let's move on to estuaries. You can see a really good example of some abandoned vessels here within an estuary. Okay, now estuaries are dynamic, complicated environments where fresh water from rivers mixes with the salt water from the sea. Now, this process, known as this mixing, is flocculation. Now, this is where fine particles clump together and settle out of the water. This is actually due to the van der Waals force. Ask your science teacher about it if you want to know more. This deposition in estuaries helps to create mudflats and salt marshes. Now, these are important habitats for wildlife. What's important to remember here is these are low energy environments. It actually becomes a little bit like a positive feedback loop, where as continued deposition occurs, the river becomes shallower and shallower towards the mouth. As a result, the water slows down even further, leading to more deposition. So mudflats really can become quite extensive over time. Just before we go into our example questions, we need to understand how both of these kind of strategies can be used to make natural flood defences. So levees can help to contain flood water. However, what's important to remember is if they're not dredged, they can end up sitting higher than the actual floodplain, as a result sometimes even increasing flood risk. Whereas estuaries help to absorb excess water. Now, that can significantly increase the lag time before peak discharge. They can also be part of managed retreat in coastal landscapes, as if they're left to their own function, salt marshes can form, which absorb the power of the waves. Obviously, we wouldn't talk about this within the rivers topic, but it is important to remember for coasts. Okay, so here we see 3 example 4-mark questions. As we can see, all of our lower course landforms depend on that keyword of deposition. 1. Explain why deposition is a key process in levee formation. 2. Explain why deposition is a key process in floodplain formation. And 3. Explain why deposition is a key process in estuary formation. Please pause the video here before you go into the model answers. Thank you for watching Bonhill Geography. Catch you in the next video.